All right, let's go ahead and get this started. It's getting late for me, so we're going to try the binomial theorem today, uh, section 5 of chapter 9 in math 126 or 124. All right, the binomial theorem is a way of expanding or finding certain terms in something. Binomial means 2a plus b to the nth power. The theorem can be used for a full-blown expansion of a polynomial or for finding a specific term. That's why it's in the sequence and series chapter or section of this. That's why it's in the sequence and series chapter is it's nothing more than a sequence with a specific type of numbers. If you never thought about it before, if you square out something uh, that's squared, you're going to have three terms. If you square out something to the third power, you're going to have four terms, so on and so forth. So that's part of it. The other part's kind of interesting. Everybody knows about Pascal's triangle. We'll get to that. It also has to do with probability, which I didn't know until I started preparing my finite math class. So that's kind of interesting. Here's Pascal's triangle. You always start with ones on the outside, and you go along the ones, and then whatever row you are on, that's the power of n. So this is like a plus b to the 0 power, a plus b to the first, a plus b to the second. You get the idea. So those numbers correspond to n. And notice that there are n plus 1 terms. There are n plus 1 terms. So if I went to the sixth row, I'd have 7 terms in my binomial. I call this the expansion. And that's how it works. You have the expansion right here. You have the binomial part and things like that. I don't know if you knew this or not. If you did, kudos. If not, you can learn something. It's actually based off probability, these numbers. I mean, Pascal just didn't sit around. This is a way of remembering it. This is like a cheat. Um, if you go to your calculators, and I'll prove this to you. Well, I don't know if I'll prove it to you or not. But this is good to remembering expansion. 1, 4, you always add to get the next one, 1 plus 4 is 5, 4 plus 6 is 10, so on. La-di-da-di-da, that's pretty good, 1 plus 2 is 3. But if you take your calculator, hit the math button, math, and you slide all the way over to PRB. I'm going to use the NCR button. This is known as a choice or choosing in probability, or a choice. It's kind of like a grouping thing. If I have 7 objects, I choose 5. How many different ways can I do that? Something like that. On your TI, you have to actually put a number in front of the C, and then you have to put a number in front of the R. Well, what's interesting and what comes from the binomial theorem is that those numbers correspond to the NCR. What do I mean? Choose. This is the R row for the number. And whatever term you want, I'm sorry, I got that backwards. This is the N. So whatever row you want, that's the N. And this is the R, or the choices. So in other words, if I type in my calculator, so I can quit. If I type in my calculator, 5, choose 3. I'm going to go to the 5th row, 3rd term. And if I do 5, I hope this works, I haven't tried it before, and 3, it is 10. So if you went 2C2, you should get 2 when you do that. 2, math, PRB, NCR 2, and you get 1. I don't understand. Oh, wait a minute. 2C2. It worked a minute ago. 2C2. Row 2, second term. Let me think about this for just a minute. 3. Let's see. Math, probability, NCR 1. That's the first term is 3. I'll have to take a look at that. It worked on my other ones. I'll have to put a little side note on that. It worked. 5C3 is 10. What's 5C4? Clear. 5, math, NCR 4. It's 5. Here's 4. Here's 3. Here's 2. Here's 1. 5C5 is just 1, isn't it? Yeah, it would be 5C5. Huh. I don't know. I'm going to have to research that some more. Yeah, I'll come back to it later when I have an answer. But anyway, that's going to be just a side note, a fun fact, but it turned out to be a stinky fact, so I'm not going to worry about it anymore. When I get it figured out, I'll let you know. But that's pretty close. There's got to be something to it. Anyway, moving on with the lesson. You get the idea that Pascal's triangle gives you the coefficients. You know, you got 1s right here, 1s, 1, 2, 1, things like that. Something to that NCR thing. I'll figure it out. So, if you go to the third, you should know that it's going to be 1, 3, 3, 1. You're going to have to know how to do these expansions on your test next week. Those expansions will be on there. You have to expand things for like a week straight in calculus. They go all the way up to the 6th power too, I believe. So the nice thing right now is x's and y's are just plain x's and y's. It's not a big deal. Another thing about the binomial expansion is, and I'm pretty sure about this fun fact, that when you add up the powers of your exponent in the same term, they always add up to 2. See how this is a 2, these are 2, that's a 2. See how that's a 3, that's a 3, that's a 3, and that's a 3. Nice. That's a 1, that's a 1, perfect. And that's a, well, that's a 0. So, you got that figured out. So anyway, that's a 3, and they add up to 3, so it's easier. Also, if you notice, the x's, they go down in powers when you go from left to right. The x's go 3, 2, 1, 0 in this cube column. Yeah, they go 3, 2, 1, 0. And the y's go just the opposite. They start at 3 and they go, you know, basically up from the back. 3, 2, 1, and 0. So if I were to do another one, if I were to do another one, x plus y to the 4th, I would have, this is how I do it. I mean, when I do it on a test or something, I go x to the 4th plus x cubed plus x squared plus x to the 1st and plus x to the 0. We're not going to pay anything for x to 0 because it's 1. And come back the other way, I do y to the 4th, y cubed, y squared, y to the 1st. And I wouldn't pay anything for y to 0 because y is just going to be 1. And then I get my coefficients from Pascal's triangle. So I have a 1, a 4, a 6, a 4, a 1. So that works for that one. It's pretty easy. So it's not too difficult to expand it out. Like I said, it's nice because you have x to y to the single power and it's to the 1st. So that's not a big deal. All right? So, moving on. Oh, I better close this. Moving on. For any positive integer n. Hey, wait a minute. Here's that NCR thing. The binomial coefficient. NCR. Oh, anyway. This just means you have a factorial button on your calculator. It's under, if I remember correctly, it's under math and probability. It's option 4. So you have a math probability button. Math, then PRB. Everybody knows that like 4 factorial means 4 times 3 times 2 times 1. It's kind of a cool button to play around with it. I don't know, you put 5 factorial and you'll get like 120. So 5 factorial equals 120. You can give it a shot if you want. 5 factorial 120. This is the old school way of doing it. But since you have a calculator, we just talked about how to do it. That N and R work. Now for some reason, something didn't work when I did that right. If I was at squared, the binomial coefficient that goes with Pascal's triangles NCR. 2 choose 1 is 2, and 2 choose 2 is 1. Anyway, we'll figure it out. So jot that down if you need to. N factorial, the non-negative integers for the coefficients. Fantastic. So on your calculator, go ahead and punch these out. And yes, this will be written on your test, and you have to know how to punch it out. Or you have to remember the equation and punch it out. So for the first one, 7 and 2. That means 7 items, and how many different ways can you choose 2 of them at a time? So with that said, probability, number 3, on my calculator. And then you hit it, and 7 NCR2 is 21. All right? Well, I hope that's what you got. For B, 6 choose 0. Well, I think there's only one way you can choose 0 objects. There's not a market on choosing 0. 14C8. You just type it in. 3003. So far, so good. And finally, 9 choose 9. Obviously, there's only one way of doing that. But there's 10 terms on the 9CR9. How does that work? I don't know. We'll figure it out. That's what we do best. We figure things out. No retreat, no surrender. No topic's too great. So there's some examples on how to do the script. And here's the binomial theorem. There are always n plus 1 terms. Check. The first term is always x to the n. Last term, y to the n. Check. We've talked about that. I feel pretty good about myself. Each succeeding term, the exponent decreases by 1. Check. And the exponent of y increases by 1. Check. I just said you go in the front, work your way down, go to the back, work your way up, fill in the coefficients. The sum is always the term of n. Fantastic. And the coefficient of the term r, xr to the y and r, or xn minus r, y, r, is n to the r. N to the r. That's what I thought I did. Maybe there's some obvious mistake I made that you guys are all like hollering at the screen, we know what it is, but I can't hear you because I'm here late at night and you're not. So we'll just have to move on the best we can. The coefficient term x to the r, y n minus r, or x to the n minus r, y to the r is n over r. Okay. So that means if I want x to the third, y 5 minus 3 is 2. That means n is 5 and r is 3. The coefficient of the term is, so what's that work out to be? 5, math, probability, NCR, 3. 10. So it's going to be 10x cubed y squared. Oh, that also works for, are you ready for this? X to the 5 minus 3 and y cubed. So it also works for 10. That's how it works, the pyramid. Interesting. 10x squared y cubed. Because you remember in Pascal's triangle, you got those things that duplicate? Well, apparently, these two are going to have the same coefficient. Well, they do have the same coefficient, but they're also going to have the same NCR. So I tried to shorten it up a little too far in saying that you just have to go to the number of terms. So this would be the first, second, third, second, first. I see. So that would be, if I was to the 0, 1, 2, 3, 4. So this would be 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 2, 4, choose 1. Let's see if that works. 4, math, PRB, choose 3. And do I get 6? No. I get 4. Yeah, we'll figure it out. All right. So here is a prime example. They aren't counting the outside terms of it as anything. So this expansion for any complex numbers, positive integers in. Oh, so the first term doesn't get an NR thing. Like we said back here, NR, it doesn't get any of that. Oh, I don't know what that means. So anyway, it doesn't get any of that. Those two are out because they're by themselves. They're always going to be 1. So that'd be like the first column, N, 0, N, N. That might work from my understanding. I can live with that. So this would be like N0 right here. And this would be like NN back here. That way you automatically get your 1s. So it goes 0, 1, 2, 3, blah, da, 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 da. And see how this 3 matches up with that number? And this 2 matches up with that number? And this 1 matches up with that number? I don't think that's a coincidence. And see how this N matches up with that number? So yeah, we're in good shape. So if I want to know the fourth term, this is the first term, second term, third term, fourth term. Okay, I have to do something like this. All right, we're in good shape. Excuse me, let's give it a shot. Okay, I know some of you are still writing. That's fine. I'll just give a little erase mark here. But I think I got it remembered. I think I got it down pat now. So, write the binomial expansion of x plus y to the fourth. We already did that. That's not too difficult. Okay? We already did that. So, let's make it different. Let's make it x plus y to the fifth, just for fun. Using the binomial theorem. All right. If I know it's going to be x to the fifth, x to the fourth, x cubed, x squared, x to the first, and x. Coming back, I know it's going to be y to the fifth. I know it's going to be y to the fourth. I know it's going to be y cubed. I know it's going to be y squared. I know it's going to be y. I know it's going to be y to 0. Now I know this one's going to be 5, choose 0. Then 5, choose 1. I'm going for it. I'm going to see if it works. 5, math, 1, 5. I think that's right. And this will be 5, choose 2. So I'll hit second and enter, go 5, choose 2. That'd be 10. 5, choose 3. 5. Oh, wait a minute. Second and enter, 5, choose 3. It's going to be 10 also. So I did 5, choose 1. 5, choose 0. There we go. Nice. I love this little eraser. Look at this little guy. All right. So 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3. What do you think 5 choose 4 is going to be? 5. I don't know. I'll find out. Second and enter. 4. You get 5. Nice. It's working. And then you get a 5 choose 5. And that's a 1. Woohoo! Nice. Now you evaluate each of the binomial coefficients. Well, we did that. The first term was 0. The second term was 1, 2, 3, 4, 5. Nice. All right. Moving on. Now, we don't have much left. This is apparently slide 7 of 7, whatever that means. Oh, that's for the old one. Here we go. Expand x minus 3y to the 4th. That's one way of doing it right there. You can put in all your x to the 4th. This would be 4 choose 0. X cubed minus 3y to the 1st. 4 and 2, x squared minus 3y squared. What they're doing is they're taking this term right here, and that's kind of an awkward way of looking at it if you've never seen it before, but, I mean, you can. I would just take x to the 4th, x cubed, x squared, x to the 1st, and x to the 0, and coming back, you're going to have negative 3y to the 4th, negative 3y cubed, negative 3y squared, negative 3y to the 1st, and then negative 3y. You can't use just plain old y because we're used to writing x, and we did the negative 3y all the way to the 4th. So this is taking the y spot in my expansion coming back the other way. And I just put in the, the numbers from Pascal's triangle, 1, 4, 6, 4, 1. And if you don't know them, well, sure, you can use the 4, 0, the 4, 1, the 4, 2, the 4, 3, and finally the 4, 4. It works the same way. Then you just tidy up your answer a little bit. X to the 4th. If I multiply 4 and negative 3, I'll get negative 12. X cubed y. Negative 3 squared is 9 times 6 is 54. 54x squared y squared. And this one's going to be minus 27 times 4, which is 108. 108 xy cubed plus 81 y to the 4th. So I usually do 3 steps. I do the x's, I do the second, or I do the first term, the second term, then Pascal's triangle. It's not too difficult. This is pretty slick, though. Like I said, I like that approach. It's got some benefits to it. Not too many negatives, just some benefits, though. So there's my approach again. Put Pascal's triangle, multiply it out. Okay? So, same way either way, however you want to look at it. No difference. And some people, like I said, like the grind of a probability look. Some people like the efficiency of just reading it and moving on. All right? Now this one, this is cool. This is when you're looking for a specific term of a binomial expansion. And when would you ever want to do that? Easy. I did some probability. And a binomial expansion gives you the complete sample space for a probability event. And then you can look for specific events using the binomial expansion. I'm doing that in Math 141. It's kind of cool. It's kind of confusing, but it works. So, if you're looking for the kth term, and you have all those powers, this is how you do it. We already talked about that. You remember on the first term we said it's 4, 0. Then we said it's x to the n, y to the 0. That's the first term. Well, you see how you're looking for the first term? Look at this. K is 1 because you're looking for the first term. K is 1 for the first term. So you take 4 to the 0, x to the n, because 1 minus 1 is 0, n minus 0 is n, 1 minus 1 is 0. It works. You just have to remember to subtract 1 and figure it out. All right? You can do that. So if you're looking for the 4th term of something, and let's say n was equal to 5, well, that's pretty easy. In the 4th term, you'd have 5, you'd have a 3, and if you want to do all that fancy figuring you can, I don't know if you just want to think it out. In the 4th term, you start with x to the, let's see, you go x5, x4, x3, x2. Okay, so it's going to be squared. And then y, if it's going to be 5, has to be to the 3rd. And look, they line up again. Isn't that nifty? I like that. So that's how you can do it. You can reason it out, grind it out. You can write down the equation. That doesn't look very nice. In fact, I'm here pretty late. Now it's almost making me nauseous. So I'm going to get off this slide. Moving on. Oh, I love this. The 7th term in the expansion, x squared minus 2y to the 11th. In the 7th term, x equals x squared, y equals negative 2y, and n equals 11. The 7th term in the expansion is what? Well, if you're looking for the 7th term, you already know it's going to be 11, 6, right? Why? Because the first term is 11, 0. The second term is 11, 1, 11, 2, so on and so forth. So we know the coefficient for Pascal's triangle is 11, 6. So we know in the 7th term, we know the first one, or the last one, is going to be to the 6th power in it, because don't these always match? And don't these have to add to 11, so that would be to the 5th. So I put x squared in right here. I'm in good shape. I'll put negative 2y in right here. And then I can work it out. Okay? So, with that said, I think I'm ready to multiply it out. What is 11 choose 6? Clear. Let's see. Second enter 11 math PRB 6. I got 462. Let's see. It's going to be x to the 10th. What is negative 2 to the 6th? That's 64. Y to the 6th. So 64 times 462. 2. My guess is 29568 x to the 10th, y to the 6th. Anybody else have a better guess? I don't know. I think if I hit the button, I'll find out. Oh, I will find out, maybe. Woohoo! Look at that. That is slick. And look at our logic. It worked. So you can't beat that with a stick. That's pretty good. So, yeah, so it works out pretty good. I like that. Yeah, you got to know that. That's high math. Sorry, that's my BlackBerry. I plugged it in. All right, so yeah, that's high math. Okay, it's just logic. It's reasoning. That's the whole idea of mathematics. Get you thinking on a regular level. Or not a regular level, on a logical level. Okay? So, you have a few minutes to get started on your homework. It's page 739, 1 through 45, every other odd. Okay, so have fun. And let's see. I think this is 9-5. So your next one is going to be on limits, I believe, your next homework. All right, I'll let you know. All right, until then, we'll see you later. Oh, homework check, almost forgot. Got to have one of those. Can't get away with one of those. So your homework check for today is going to be on page 9-1, I believe. Let me see. Wasn't ready for this. 12. No. Actually, it's on Yeah, 721. So, homework check on page 721. Let's see. You went. Let's see. No, actually, I'm sorry. We'll do 712. Page 712. Yeah, we'll do all those problems I did for you when I was gone. Remember I went through and did all your homework for you? Yeah, I still got it. So, you can do, let's see, 5, 10, 15. Well, that's a good one. 20, 25. Okay? 5, 10, 15, 20, 25. All right, there you go. So get that done, get it turned in. There's some papers that Rachel can hand back up top. So, or anybody can hand back, I guess. They're up on the ledge. So I'll talk to you later. And hopefully I'll see you soon. Bye. Don't forget, homework check. Get them turned in 5 for 12 or 5 for 10. Now, how do I get out of this thing?